So what we're going to talk about here is about the introductory electronics. We've already discussed a bit about the thermionic emission and the cathode rays. We will discuss this concept in quite a detail, and we will also that will further lead to use of an oscilloscope. So when we come towards 24.2 and 24.3, I'll reopen this part of the component and we'll discuss this. So state that electrons are emitted by a hot metal filament, right? You should be able to, by the end of this lecture, you should be able to understand that electrons are emitted by a hot metal filament, and you should be able to explain that to cause a continuous flow of emitted electrons, it requires a high positive potential and a very low gas pressure. These two things are very important. High positive potential and a very low gas pressure are essential for the continuous flow of electrons. After that, we will discuss the deflection of electrons, electron beams by electric fields and magnetic fields, right? And you are a bit familiar about this concept that the flow of electrons is from negative to positive and is in the opposite direction to the conventional current. So these are the 3 to 4 things that we will discuss in this lecture, right? In the previous lecture, we have already, discussed that when the electrons, when the cathode is heated, what happens? The cathode emits electrons, right? The electrons comes from the hot cathode, and when the hot cathode is basically a fine filament which is heated to a high temperature, and due to that high temperature, the electrons are emitted from the filament, and this process is known as the thermionic emission, right? Is that clear to everyone? That what is thermionic emission? Ji, Afraz, Abdullah, Atif, Azan, Asim Mirza, are you do you know what is this concept of thermionic emission? Ji, what is thermionic emission? Abdullah, Atif, what is thermionic emission? Samir, Ibrahim, what is thermionic emission?
सर जो आपने बोर्ड पे लिखा होता है वही होती है
नहीं, what is thermionic emission? I'm just asking you. क्या होता क्या है इसमें?
Sir, the metal is electrically heated and the electrons gain energy to escape from the surface and they are shooted away from the metal.
Okay. So basically, in a metal, you know that each atom has a few loosely bound electrons, outer electrons, and they move randomly through the material. So you know that in the normal case, these electrons are held by strong attractive forces of atomic nuclei. These electrons are held by strong atomic forces of the nuclei. So what happens when the metal is heated? Some of the electrons they gain enough energy to escape from the outer shells, and this process leads to thermionic emission. And this is what thermionic emission actually is, right? So when the hot filament is heated up, the yeah yeah जी
सर
जी
सर
जी जी
अयान को क्लास
सर
में
वो
ऐड कर ले।
मैंने
हाँ
किया ऐड अयान मुझे आ नहीं रहा यहाँ पे दिखाई नहीं दे लेट मी सी जी डू यू हैव अ क्वेश्चन सामिर डू यू हैव अ क्वेश्चन
नो सर
okay Ayan is not coming here at the moment when he'll come I'll add him okay do you anyone who has a question right now सबको क्लियर है ये जो मैंने बताया अभी जी सबको क्लियर है कि थर्मियोनिक एमिशन क्या हो रही है किस लिए होती है अफराज अजान इब्राहिम आरिफ समीर सादमान शाहजेब खान इज दैट क्लियर
यस
जी
सर।
वॉइस ओके गुड शाहजेब आपको भी क्लियर है कैन यू हियर मी
यस यस सर।
okay so how can we produce thermionic emission you know that thermionic emission can be produced by electrically heating a fine tungsten filament and this can be achieved by passing a current through the filament आपके पास ये जो filament होगा इसमें you will pass the current by giving it a low voltage let's say 6 volts when you give it a low voltage that is 6 volts what happens the filament gets heated up and when the filaments get heated up what happens it emits electrons right it emits electrons and this is what happens right? And this is what cathode rays is all about. अच्छा, अब उसके बाद हम लोगों ने थोड़ा डिस्कस किया था इलेक्ट्रॉन गन के बारे में, राइट? तो इलेक्ट्रॉन गन में क्या होता था कि व्हाट, मैं थोड़ा सा यहाँ पे रिवाइज कराऊंगा आपको कि व्हाट हैपेंस इन इन इलेक्ट्रॉन गन. सो एन इलेक्ट्रॉन गन कंसिस्ट ऑफ, अजाना से मिर्जा, मुझे अयान जुबैर का वो आ नहीं रहा, इनविटेशन आ नहीं रहा, वो आएंगे तो मैं उनको ऐड करूंगा. ही इज नॉट देयर, आई कैन नॉट सी हिम, राइट?
ठीक.
चलिए दोबारा सेंड करें रिक्वेस्ट, तो मैं यहाँ पे एंटर करता
Okay.
हूँ. ओके, सो यू हैव दिस कैथोड and you have this anode. Cathode is attached with a negative supply. ठीक है, ये देखिए नेगेटिव के साथ अटैच्ड है, इसलिए हम इसको कैथोड कहते हैं, नेगेटिव टर्मिनल. और आपके पास पॉजिटिव जो है, हाई पोटेंशियल जो है, वो अटैच्ड है एक सिलेंड्रिकल एनोड, जिसको हम एनोड कहते हैं, राइट? अब ड्यू टू द हाई पोटेंशियल डिफरेंस between the cathode and anode, the cathode rays are accelerated. Tahamusa, is that clear? Due to a high potential difference, because negative is attracted towards the positive terminal, what happens? The cathode rays are attracted towards the anode. Negative जो है वो attract करता है, positive attract करता है negative को. Taha Musa, this was your question, right? In the previous
जी
class,
सर.
right? So the negative electrons are attracted to the positive anode due to a high potential difference. You see that there is a high potential difference of several thousand volts, kilovolt में, ये देखिए kilovolt में. And there is low pressure. Why there is low pressure? What is the reason of low pressure? Can anyone tell me? G.
So to prevent deflection.
To prevent deflection with the air molecules, right? There is low pressure inside this tube. ये जो आपके पास इलेक्ट्रॉन गन है, जिसमें आपके पास एक कैथोड है, you have an anode. Low pressure to that will basically what happens, because of that there are no deflections. तो ये दो चीजें आपको चाहिए for a continuous supply of electrons, as we discussed in the syllabus. You see, this was the syllabus, and in A part we have already discussed that state that electrons are emitted by a hot metal filament. ये तो हो गया. दूसरा मैंने आपको बताया that explained that a cause of continuous flow of emitted electrons requires number one, high positive potential. आपको high potential difference चाहिए, ठीक है, अभी जो मैंने आपको अभी डिस्कस किया आपके साथ. And number two, you need a very low gas pressure. We have already discussed this, that you need a very, very low gas pressure. So these two things are essential for the acceleration of electrons.
सर हाई पोटेंशियल डिफरेंस इसलिए ताकि इलेक्ट्रॉन्स वो अट्रैक्ट कर सकें एनोड पर, मतलब कि एक्सेलरेट करें उधर.
एक्सेलरेट करें, बिल्कुल ऐसे ही एक्सेलरेट करें, ठीक है. तो आपके पास जो ये थर्मियोनिक इमिशन से इलेक्ट्रॉन्स एमिट हो रहे थे, वो सारे के सारे एक्सेलरेट कर रहे थे एनोड की तरफ, ठीक है.
सर तो अगर हम किलोवाट्स नहीं भी प्रोवाइड करते, फिर भी उन्होंने अट्रैक्ट तो होना ही है एनोड पर.
नहीं, वो ज्यादा स्पीड से जाएंगे, बहुत स्पीड से जाएंगे और स्ट्रेट जाएंगे. मतलब ये होगा कि दे विल बी एबल टू पास थ्रू दैट टर्मिनल, क्योंकि आगे आपने जब आप इसको एक्सेलरेट करवाएंगे तो आगे हम लोगों को इनकी स्पीड हाई चाहिए. you'll see later on we need a high speed of electrons later on, ठीक है, since we are going to do CRO, तो उसमें हम लोगों ने
ओके सर.
डिस्कस करना है सर. अच्छा, let's move ahead, right? So a high positive potential is connected to a cylindrical anode. I'm going to write here a high positive potential, a high positive potential is, which is several thousand volts, as I've already discussed, several thousand volts is connected to a cylindrical anode, right, which is positive. Anode is a positive terminal. The electrons will be accelerated at high speed. The electrons will be accelerated at high speed, and they shoot straight through the hole of the anode as a fine beam of electrons. Straight जाएगा बिल्कुल. ये देखिए बिल्कुल ऊपर, ये देखिए स्ट्रेट जा रहा है, ये बीम जा रहा है. These are the beam of electrons. ठीक है? So they pass straight, they shoot straight like a gun. The electrons will be accelerated at high speed and they shoot straight through the hole of the anode. ठीक है? In a fine beam of electrons. And we call this beam of electrons the cathode rays. We also call these beam of electrons as cathode rays as they are produced by the negative terminal, which is the cathode. ठीक है? We refer to these electron beams, we refer to these electron beams as cathode rays, ठीक है, as they are produced from the cathode or the negative terminal or the negative electrode. ठीक है जी? Is that clear to everyone? Abdul Rafe, Ibrahim Arif, Ibad Usmani, Saad Aman, Sarmad, Shahzeb Khan, Shayan Shehzad, Taha Musa. Is that clear to all of you? Ji.
Yes, sir.
Good. Now I'm going to talk about their deflection in the electric field and their deflection in the magnetic field. See, since these electrons are passing, they can be deflected and they can be, uh, they can be deflected in an electric field, they can be deflected in a magnetic field. ठीक है? तो मैं आप लोगों को अब बताता हूँ कि किस तरह से ये इलेक्ट्रॉन्स डिफ्लेक्ट हो सकते हैं इलेक्ट्रिक फील्ड में और मैग्नेटिक फील्ड में. राइट? Let me open another page for this because यहीं पे बता देता हूँ. Let me. So deflection of electrons by electric field. Deflection of these electrons. I'm simply going to write deflection by electric fields. अच्छा, अब आप इलेक्ट्रिक फील्ड कैसे सेटअप कर सकते हैं? आप इलेक्ट्रिक फील्ड इस तरह से सेटअप कर सकते हैं. लेट से आपके पास एक कैथोड रे थी, कैथोड था, और दिस वाज लेट से द कैथोड, राइट? और आपके पास यहाँ पे एनोड लगा हुआ था. लेट से दिस वाज द एनोड.
सर
ठीक है?
अयान अभी भी लॉबी में बैठा हुआ है.
यार अयान का मुझे आ नहीं रहा, पता नहीं, आई डोंट नो. मैं चेक करता हूँ दोबारा. मुझे यहाँ पे आ नहीं रहा उसका. उससे चेक करें उसका सही आ रहा है, बिकॉज मैं चेक कर रहा हूँ. आई कैन नॉट सी हिम. ठीक है? यहाँ पे कहीं पे नहीं आ रहा. वैसे मैंने लेक्चर रिकॉर्ड कर रहा हूँ. ही कैन, बट जस्ट अ मिनट.